Hello students, how are you all? I think this will be the last lecture of the theories of the chapter number 1 of class 10 science, that is chemical reactions and equation. So up till now we have almost completed each and every important topic, such as for example, what do we mean by chemical change and a physical change, what do we mean by balancing, why do we need to balance a equation. So in between there were two topics, that is each and every chemical change has a chemical reaction, and each and every chemical reaction can be easily represented in the form of a chemical equation. Then the topic was balancing of the equation, why we need to balance the equation, adding extra informations into the equations. Then we have different types of reactions, that was combination reaction, decomposition reaction. We also had combination reaction, decomposition reaction, displacement reaction, double displacement reaction, precipitation reaction, oxidation, reduction, redox. In between we also learnt about something exothermic reaction, endothermic reaction, and the examples. So up till now we have completed this much topic, and the last two remaining topic of this chapter are corrosion and rancidity. So they are one and the same thing, but corrosion is used for the metals. Corrosion word is used for the metals, and generally rancidity is used for the food items. But the similar processes are involved in both corrosion as well as in rancidity. So what do we mean by corrosion? Corrosion is applicable on metals, the eating away of metals, that the destruction of the metals. Metals gets eaten away when they react with their environment. For example, when iron reacts with oxygen and water, iron in presence of oxygen and water forms rust, oxides of iron, that is brownish powder on the iron vessels, iron articles, on the benches, on the chairs, everywhere where iron is present. After some time we see a brownish powder or a brownish layer on the surface. That is corrosion. That is corrosion of iron, that is oxides of corrosion. Sometimes not only oxides, sometimes carbonates are formed, sometimes hydroxides are formed. It means each and every metal reacts with their environment differently, and different types of compounds are formed. For example, when iron in presence of oxygen and water, it forms iron oxide, Fe2O3 XH2O. So this is the moisture present in it, and this is reddish brown in color. This is reddish brown in color. What is the color of iron? Iron is generally grey black. It is grey black, clear, dark greyish color, or you can say black color. So when iron is kept in presence of oxygen and water, it forms Fe2O3 XH2O. It means it is a moisture present. Water is not reacted, but it is in the form of a moisture. So this compound is formed, and this is known as corrosion of iron. Clear. Now for example, silver. The silver articles or silver ornaments turns to the black. Why? Because they react with hydrogen sulfide. Hydrogen sulfide is a gas present in the atmosphere. And it is converted into silver sulfide, Ag2S, which is black in color. Copper in presence of carbon dioxide and water, turns into copper carbonate and copper hydroxides. These are green in color. So these are the compounds. See, iron turns into the Fe2O3 XH2O, that is hydrated ferric oxide. Now silver turns into the silver sulfide, copper turns into the copper carbonate or copper hydroxide. So these reactions are known as corrosion reaction. Why? The properties of the copper has been changed. But why do corrosion takes place? Why do we study? Why am I teaching? For the stability of anything. So as compared to the iron oxides are more stable. as compared to the silver. Silver sulfide is more stable as compared to the copper. Copper carbonate and copper hydroxides are more stable. Copper carbonates and copper hydroxides are more stable. Here sulfide is more stable as compared to the silver. So for the stability, for gaining the stability, but in gaining the stability, metal gains the stability, but we lose our metal. We lose our metal. This is a destruction of metal. This is very much economically lost. There is a huge economical loss by this corrosion reaction. See, now the silver turns into the black color, then it is no use for our ornaments. Copper turns into the copper carbonates and copper hydroxide, then that copper won't be useful. Similarly, iron when converted into iron oxide, it is not useful for us. Why? Because its properties are changed. Why iron is used in many of the things? Most of the articles are made up of iron. Most of the things are made up of iron. Why? Because of the hardness of the iron. Because of the hardness. Iron is a very hard metal. Iron is a very hard metal. And because of its hardness, we can build many machineries or we can build many things because it is hard. Now, as and when it is converted into this reddish brown powder, that is Fe2O3 hydrated ferric oxide. Hydrated means moisturized iron oxide. Iron is also known as ferric. It is a +3 and so it is also known as ferric oxide. So this hydrated ferric oxide, this hydrated iron oxide is in the powdered form. It doesn't have any hardness. It is stable form of iron, but it do not have the properties of iron. So we cannot build anything from this one. Clear? So it is a total loss. So there are many different types of corrosion reaction. We have learnt about the 3 different types of metals which are most important for our class 10. Now out of these 3, one rusting of iron, that is corrosion of iron, is the most important corrosion reaction. Why? Because 90% of the things are made up of iron compounds, and now if the corrosion of iron takes place, then there is a huge loss. Crores and crores of rupees are wastage because of the corrosion of iron. Crores and crores of rupees are wastage every year. Every year thousands of crores of rupees are wasted because of the corrosion of iron. So we have named this corrosion as rusting. Is known as rusting. Rusting of iron. It has a special indication about the corrosion of iron, that is known as rusting. It is a corrosion of silver. It doesn't mean rusting. Rusting is especially used for iron. We cannot say that this is a rusting of copper. No. It is only used for iron. Corrosion of iron is also known as rusting. It is a corrosion of silver. It is a corrosion of copper. But corrosion of iron can be also represented as rusting. If we say corrosion of iron or we can say rusting, then it means degradation or destruction of a iron metal where it reacts with surrounding oxygen, water, different chemicals. So it is a destruction. What do we mean by corrosion? It is a destruction of metal when it reacts with different types of compounds in its environment, chemically or electrochemically. So when chemically any metal reacts with compounds present in the environment, it becomes stable, but the properties are degraded. That is the destruction of metal, and the process is known as corrosion. And the process is known as corrosion. Clear? But especially corrosion, here iron gets converted into iron oxide, which is reddish brown, that is easily visible. If we are wearing any silver ornaments, for example ring or a chain or any other ornament, then on a long term silver gets converted into black color. The silver ornament somewhat, the layer of a black layer is found on the silver ornaments. Why? Because that silver reacts with hydrogen sulfide present in the atmosphere and forms silver sulfide. Similarly, on a copper vessels, for example water tank of a copper water tank, clear, which are mostly present in our home, or we have some different types of copper vessels. Then on copper vessels we see the green patches. There is a green layer formed on the copper vessels. Clear? So why? That is because of the copper carbonate and copper hydroxide formation on the copper vessels. Clear? Getting it? Now out of this reaction or many of the reactions, this reaction is quite fast. This reaction is quite fast. Why? Because iron is more reactive as compared to the silver and copper. Iron gets easily reacted. Iron gets easily reacted with the copper and as compared to the copper and silver. Silver and copper are less reactive elements. Copper and silver are less reactive as compared to the iron, so it gets easily reacted. Second thing, oxygen and water are present in the abundant amount. Oxygen and water are present in abundant amount. There is 21% of oxygen in the atmosphere. There is huge moisture during the rainy season. Now silver, hydrogen sulfide when reacts with silver, it forms silver sulfide, which is a corrosion of silver, black in color. But the amount of hydrogen sulfide in the atmosphere is quite less. The amount of hydrogen sulfide present in the atmosphere is quite less as compared to this compound. These are easily available. This is not easily available. So the corrosion of silver takes time as compared to the corrosion of iron. Now third, first point, copper is less reactive than iron, so it will react at a slow speed. It is react at a slow speed as compared to the iron. Second, carbon dioxide is also in the lesser quantity. There is only 0.03%. 0.03% of carbon dioxide gas in the atmosphere. Oxygen 20%, that is thousands of times more than the carbon dioxide. So copper gets less reactive, that is a slow process as compared to the corrosion of iron, Clear? So these are the different types of corrosion that we are going to learn. Now write it down, these reactions, and examples, each and everything. What are the colors of the compound? Silver is in silver color, clear, or grey color. You can also say silver, it is in grey color, it gets converted into black color. Iron is black in color, gets converted into reddish brown. What is the color of copper? Copper is reddish brown. The copper metal is reddish brown, but the reddish brown color of copper gets converted into green color, that is rusting, corrosion, my mistake, that is corrosion. Rusting can only be used for iron. Clear? Now how can we prevent corrosion? This topic is not included in our chapter. This is included in the chapter number 3. Clear? That is metals and non-metals. So it is not included in this chapter, but let us quickly revise. You don't have to write, you don't have to remember in this chapter, but you know corrosion. So if you want to stop the corrosion of iron, then corrosion of iron takes place because of oxygen and water. Then stop the flow of oxygen and water towards the iron. You should do anything, such that iron and oxygen or iron and water doesn't come in contact with each other. So how can we prevent? By applying the color, by applying the paint on the iron articles or any iron thing, so that it cut off the supply of oxygen and water. What is the second way? You can apply oil or grease on iron vessels or iron articles or iron machines, applying oil and grease, which also prevents the flow of oxygen and water. Clear? We can also put a layer of zinc. How? For example, we have a iron article. Now I am applying a layer of zinc on it. Clear? Then how can you prevent? Does the corrosion of zinc doesn't happen? Zinc is also a metal, and that zinc metal is even more reactive than the iron. That zinc metal is more reactive than iron. So the corrosion of zinc should be taken at a more higher speed than the iron, as iron is more reactive than silver and copper. So the reaction of the corrosion, that is rusting of iron, takes place at a higher speed as compared to the corrosion of silver and copper. But zinc is even more reactive than the iron. So it is quite obvious that the corrosion of zinc will happen at a more higher speed than after that. But as the corrosion of iron is converted into powder, when the corrosion of iron takes place, it is converted into the powdered form. So it means this Fe2O3 is a reddish brown powdered form. It is not in a hard single layer, it is in the small particles. But when this corrosion of the zinc takes place, the corrosion of zinc do not take place in the powdered form. It forms a layer of zinc oxide or any other zinc compounds. Clear? Getting it? So here not only zinc is present, after the corrosion of zinc a full layer of zinc takes place. Full layer of zinc is present on the surface of the iron articles, which is not removed. It doesn't get removed from the iron articles. So now if it is converted into zinc oxide, now this layer is of zinc oxide, why the corrosion of zinc takes place into the zinc oxide. Now this is a layer of zinc oxide which do not gets removed. So now iron article is actually protected. The iron article inside is actually now protected. Why? Because of the corrosion of zinc. Because of the corrosion of the zinc, the layer of zinc compound is found on the iron articles or iron vessel or iron, anything of made up of iron. Clear? The similar thing also happens when corrosion of aluminium takes place. The same thing as compared to the zinc, aluminium takes place. So we can use aluminium vessels in our house. There are many aluminium vessels that are being used into the house. Why? Because of the corrosion of aluminium, it forms aluminium oxide. It forms aluminium oxide. That also forms a single layer on the vessel. That also forms a single layer on the vessels which doesn't get removed and which is not harmful for us. These compounds are harmful for us. This compound is not harmful for us. So if some of the atoms or some of the molecules of aluminium are added into our body, then it doesn't harm us as this compound harm us. Clear? So we cannot use iron vessels, we are using aluminium vessels. Clear? Getting it? Or we can form the alloy of iron. To stop the corrosion, we can, or to decrease the speed of corrosion, we can form the alloy. What do we mean by alloy? Alloy is a mixture of two or more metals and non-metals. If we are mixing Fe with carbon, then it forms steel. See, this is a mixture, that is a mixing of iron and carbon, it forms steel. Then this is known as alloy. Because it is a mixture of metal and a non-metal. So there can be a mixture of metal, two metals, one metal and one non-metal. It can be a mixture of any of the elements and it is known as alloy. When iron is mixed with nickel and chromium, then it forms stainless steel. Clear? What do you mean by stainless steel? Stainless steel means in which the rusting is not possible. In steel, rusting is possible but at a very slow rate. In stainless steel also rusting is possible but almost at a negligible rate. It means we can say that it will not get rust. So that is the stainless steel. Clear? So it is a mixture of many metals, two or more metals and non-metals. So it is also known as alloy. It is also an alloy. So when two metals or non-metals are mixed with each other, then it forms a alloy and new properties of alloys are obtained. New properties of that compounds are obtained. So we can obtain our determined properties or the required properties. So hardness of the iron is also maintained, as well as we have removed the problem of rusting. And the hardness of the iron is maintained. See, steel is not as hard as the iron. But in most of the places, for example, vessels, in kitchen, vessels can be made of this steel or stainless steel. Clear? Why stainless steel? Because we do not need too much hardness in the vessels. We don't need to fight a war. We don't need to hit anyone with a vessel. So it shouldn't be hard. So it's somewhat hard as well as it is prevented from the rusting. So we can form a alloy. Now let us move to the last topic of this chapter. What is the last topic of this chapter? That is rancidity. See, what is the corrosion? Corrosion is the destruction of a metal, destruction of any metal. What is the rancidity? It is a destruction of food. How? By any chemical process. When the food containing oil and fats, comes in presence of, in contact with the oxygen or generally air, it gets oxidized. Clear? So this is oxidized food. Clear? So that is known as rancid. That are known as rancid. and the whole process is known as rancidity. Clear? And the process is known as rancidity. When the food containing oil and fats, comes in contact with or reacts with oxygen, they gets oxidized. That is a quite simple. There is oxidation of food material. That is the oxidation process. But oxidation of food, which type of food? In which oil and fats are present. The food in which oils and fats are present, when comes in contact with oxygen, they gets oxidized and forms and converts into rancid. Clear? How can we know that any food is rancid or not? How can we know that any food is rancid or not? There is a foul smell coming from that food. There is a foul smell coming or bad smell coming from that food. Or if we taste that, then that is also not good in taste. So if the foul smell is coming from the food or it is not good in taste, then we can say that it is rancid, and that is the process of rancidity. That is the oxidation of oil and fats present in the food particle. So that is a simple process, that is oxidation of fats and oil present in the food converts it into rancid by the oxidation, and the process is known as rancidity, How can we prevent the food from the rancidity? So we can prevent by the cutting of the supply of oxygen. The same thing we were doing in the corrosion, but here we cannot paint the food thing. Clear? We cannot paint the food items. So how can we supply? By, for example, Balaji packet, a packet of chips of Balaji. Clear? So here there are chips, but most of the space is filled with the air. Then this air will be nitrogen. So this any packet of the chip contains nitrogen. Why? Because nitrogen is a non-reactive gas. So no oxygen is present here, so there will not be a process, so we can slow down the process of rancidity. Clear? Similarly, the chip packet of Lay's wafers, it also contains nitrogen. So all of the chip packets that are filled with nitrogen gas do not get rancid, so it can be preserved for longer period as compared to it is preserved in open air. Clear? Second, by adding antioxidants. What do we mean by antioxidants? It means there are some type of compounds which prevents the reaction of oxygen, that do not allow oxygen to react easily. So it can be preserved for a long time, and generally we are known them as preservatives. They are known to us as preservative, but they are known as antioxidants. What do we mean by antioxidants? The compounds which stops the reaction of oxygen are known as antioxidants. Clear? Or we can keep the food in the freezer or freeze. Clear? So it means decreasing the temperature. If we decrease the temperature, then any of the chemical process gets slowed down. If we increase the temperature, the speed of the reaction increases. If we decrease the temperature, then the speed of reaction decreases. So at a low temperature, oxygen cannot easily react with any of the food containing oil and fat. But on a longer period, it cannot easily react. The process slowed down, but the process do not stop. It just slowed down. So the food item which is going to be rancid in 1 or 2 days can be preserved for 5 to 6 days or 7 days. Clear? By using the freezer. Clear? Or we can keep the food in airtight container. Clear? When we buy any food in a freeze cold containers from the supermarket, they are kept in a vacuum. They are preserved in vacuum. It means totally the whole air has been sucked from that packet. Why? Because oxygen is also sucked from the packet. If oxygen is not present in that packet, then it cannot react and the rancid cannot be formed. So compounds cannot get rancid and the rancidity can be stopped. So these are the ways how we can prevent the food by packing the food items with or flushing the air into it Which air? Nitrogen, as it is non-reactive. By adding antioxidants which stop the oxidation reaction or prevents the reaction with oxygen, by freezing it or keeping it at low temperature or packing it in a airtight container. So these are the ways how we can prevent food particles. Clear? So here all of the chapter number 1 is completed. So in the next lecture we are going to start the solution of in-text and exercise question. Hope so you have been solving in-text and exercise question as per the lecture is going on. Clear? Now in the next lecture you have to just tally that the questions or answers written by yourself is correct or not, or how you can improve the question that you have written. So you have to just check. So before starting of the next lecture, the homework should be completed. And what is homework? The classwork as well as all of the in-text and exercise questions of chapter number 1. In the next lecture you have to just check whether the answer written by you is correct or not. Clear? Thank you very much.